Okay, welcome to our second video on secondary mathematics. I have a question from Trigonometry 1. The question reads, given that sine O into bracket 2 over 3x plus 20 degrees minus cosine of 5 over 6x plus 10 degrees is equals to 0. Without using mathematical table or a calculator, determine tan into bracket x plus 20 degrees. Okay, so I want to give you a prerequisite information regarding the trigonometric identities, so that when we embark on this problem, you're going to see how the same knowledge is going to be applied. Okay, so if I, under the solution, I draw a right angled triangle here, and then I designate this side to be C, because this is right angled, and this to be my A, this to be my B. I label this angle as theta, so this is going to be, this angle over here is going to be 90 minus theta. All right, so if I come right here and get the ratios, let's say sine of theta, you know it is always opposite over hypotenuse, then this is going to be, our opposite is this one, then our hypotenuse is this, so we are going to say it is B over C, and you allow me to put that one as equation number 1. Let me take cosine of 90 minus theta, for example, this angle over here. So cosine is equals to adjacent over hypotenuse, so this is good, our adjacent to the angle, and this is the hypotenuse, and this is going to be equal to B over C. Okay, equation number 2. Alright, if you look at the two equations, that is 1 and 2, you notice that sine of theta is equal to cosine of 90 minus theta, right? And even if we did sine of 90 minus theta, which I'm leaving for you to confirm, you would notice it is equal to cosine of theta. Okay, so using this fact, we can now tell that these two angles are acute, meaning that if you sum them, you're going to get 90, and we can prove that. We say theta plus 90 minus theta, see what this is going to be equal to. We have theta plus 90, then plus times minus gives me minus theta, and then when you sum them up, you're going to see this is theta minus theta plus 90, and this is going to give me 90 degrees. So it means the two angles add up to 90. So we can use the same fact to solve this problem here, so long as you have sine of something and cosine of something, right? Fine, so we are going to have our solution extended down here. So we say sine of 2 over 3x plus 20 degrees. We take cosine of 5 over 6x, have enough space, plus 10 degrees is equals to 0. So if we take these two angles and we add them and then equate to 90, that is quite legitimate from the previous fact that we have observed there. So that is plus 5 over 6x plus 10 degrees is equals to 0. So taking the like terms together, this and that is going to give me 3 over 2x, if you sum them up, plus 30 degrees is equals to, so you're not supposed to say 0 here, you're supposed to say 90 degrees, because we confirmed that both acute angles add up to 90. That's the previous fact, so I apologize for having written 0 instead of 90 degrees. Okay, so then this becomes 90. And so if you solve for the value of x by taking 30 on the other side, you will notice that is equal to 60, and this tells me that x is equals to 60 times 2 over 3, which makes it 40 degrees. Okay, so the first thing is to get the value of x, so that now when you go back to the question where it is saying you solve for the value of tan of x plus 20, and in this case we are not using a calculator, you'll be able to get the correct answer. So what is tan of x plus 40 degrees? You notice, because not 40 but 20 here, so this is 20 degrees. So tan of x plus 20, where x is 40, that gives me 60 degrees, and this is one of the special angles, and you know that comes out as root of 3. All right, so that becomes the answer to our question. Okay, and in case you would want to know where that one has come from, you can always go back to the proof of special angles. So if this one is 2, this is 1, this is square root of 3, so this is always 60 degrees, this is 30 degrees. And so if you want tan of 60, tan is opposite of adjacent, so it is opposite of adjacent, which is equal to square root of 3. All right, so, and that's how it is done. Thank you.